Even though quantum mechanics still continues to be a bamboozling topic for many mathematicians and physicists. In fact, Niels Bohr once said, "If you have not been shocked by quantum mechanics, then you have not fully understood it enough." It's just so, we just cannot, really guess all the time, the behavior of, atoms and particles and electrons, because they behave in such a way that it just, deviates so much from classical physics. But amidst all these mysterious wonders, they do have great practical applications, including quantum computers, which are praised to be better than classical computers because they can compute faster, they hold more storage, and they usually provide less error when it comes to calculations rather than the errors found by calculations done by classical computers. And I recently found an article that actually explained one of the biggest breakthroughs in the field of quantum computing in 2024. And that is Google has just released, but it's not fully out yet, so it's just more like a concept of their next quantum computing chip known as Willow, like the willow tree. And I first saw the article and it was mind-blowing. The article first talked about how quantum computing really works, as well as some of the drawbacks. And the specific drawbacks the author mentioned were mostly pertaining to the idea of quantum calculation errors. Specifically, the quantum computer spitting out a result that is either incorrect or you do not want. And it's not like a desired result. The article does talk about a couple reasons why these errors happen. One is the idea of quantum noise, which talks about even if there's no audible noise that us humans, our ears can decipher, there's this quantum noise that is inevitable, unfortunately, for quantum computers because electrons, atoms, and particles, all fundamental for quantum mechanics, are always moving. And if these atomical bodies move in a certain way, they can interfere with some of the movements of the atoms that lie inside quantum computers. The other cause of error is also, there are so many other causes of error, including flips and dephasing. I mean, when you have, basically atoms are moving inside the quantum computer, and they have to move a certain way in order to, get the result you want or get a correct calculation. Bit flipping is, like all computers, quantum computers operate in a system of bits of 0 and 1. But if the computer meant to use a 0, but instead used a 1, this can create several calculation mistakes. Dephasing is when they take an atom's ideal state of vibrating or moving or jiggling around in a certain way too early. This can also create problems. It's kind of like taking the steak out of a pan way too early before it's actually done cooking. So you're gonna get undercooked meat, and it could cause food poisoning if you eat it. So Google's new chip Willow is doing is they're using new ways to tackle these kinds of errors, and the best ways to efficiently try to bring the error level down so it does not effectively interfere so much with the necessary processes of quantum computing. They do this by one method of redundancy, which is you have, let's say, one computer wants to print 1 to another computer. This number 1 may contain an important message, but there's a chance that that first computer, we will call it Alice, the second computer, Carol, Alice might accidentally print a 0, and Carol would get the incorrect message. But what Alice, the quantum computer, can do with Willow's chip is to print, triplicated. Duplicated, but it's triplicating, printing 1 3 times. So even if one of the numbers gets changed to 0, the other computer, Carol, knows that I was meant to set a 1, not a 0. But there's so many other new methods, and I feel like this is a great step for us to fully understand the nature of quantum computers, especially in practical applications. And hopefully we can see that maybe with lesser chances of errors through redundancy and like exponential like increase of preventive measures, it can be helpful for quantum computers to be maybe like released onto practical applications faster. So yeah.